Hello, I'm Nemo. Let's look at the function files of our simulation. There are 4 function files: draw AND gate, draw NOT gate, draw OR gate, and draw XOR gate. And the structure of these 4 functions are actually very similar. Their job is to draw the gate at the given position and with the given input value. And so they only draw the gate once. So if we want to make animation, we have to call the function again and again with different input value. So then we can see that the gate on the plot change accordingly. So let's look at the input argument of the function. The input argument of this function actually consists of 4 parts. At the first part, we pass in the AX parameter. It is actually a handle of the axis that we are going to plot onto, so that we actually plot each of these gates onto the same figure. So like this, the AX. So every time we call AX inside this draw AND gate function, we pass this AX into the plot function, so that we can plot every lines and every dot onto the same figure. Okay, the second part of the input argument is the position that we should draw the gate, and these positions are given outside of the function, so that we know where should we draw a line and how long should the line be. And because we are given a fixed point in the graph where is the input and where is the output, so we can use some simple calculation in the function to find out where should each chopsticks be placed into the graph. Okay, the third part of the input argument is the delta value. Delta value is a parameter that determines how much should the chopsticks shift when the value change. For example, if the delta is 15, then when the input change from 0 to 1, the input stick should rise 15 units in the animation. So the delta is the parameter that we use to define how large the motion should be according to the change of the input value. And finally, the fourth part of the input argument of the function are the 2 input value, and they are the value between 0 and 1, and they represent the data that our gate is going to handle. So finally, there is a return data of our function, and it is also a value between 0 and 1, and so that we can pass this value into the next gate. And it's into the next gate, yes. Okay, so let's look at the function. Look inside the function. Then the first part of the AND gate function, we swap the input 1 x coordinate and the input 2 x coordinate if input 2 is smaller than input 1, which means that we always want that the input 1x is smaller than the input 2x, and we change the value accordingly, so we can guarantee that the width of our gate is always positive. And second, we calculate the value out of our gate. It is a value between 0 and 1, and it is just some simple logic. It is the maximum of the common mode and 0. And this code, these lines, just draw the sticks of the gate, and we use calculate all the position of each sticks and then draw them. Okay, and finally we draw the value of the gate. We show the value of the gate by a text function. Output value of the gate. Okay, and each function is also other functions are very similar. Okay, the difference is that in the XOR gate function, we actually call the other three functions, because the XOR gate consists of the AND gate, OR gate, and the NOT gate that we previously written. Okay, that is the end of the demo of our simulation. Thanks for your attention.